Hello, once again. Good morning to you all. So today for a change, we'll try to do coordinate geometry. And in your course, only two dimensions are involved, as I've seen the question paper just now. So we will try to do that. And then before I go into it, you remember I had given certain lessons, online of course, and we have finished up to the circle. And what is left out is the parabola, ellipse, and the hyperbola, right? Okay, but then I would like to digress backward, and try to recall something that we have already done and which you have also already done in your school days. Like for example, the area of a circle. Suppose you know the coordinates of the three vertices of a triangle, then you know that suppose this one, right? A has got the coordinates x1, y1, and B has got the coordinates say x2, y2, and C is the last vertex. X3, y3 is the coordinates. Okay, coordinates. And we call it Cartesian coordinate. Let's try to remember a little bit of this history. Who in fact started coordinate geometry, okay? So when we come to that, you must remember this name, that is René Descartes. René Descartes, this gentleman, born in 1596, so far I remember, and he passed away in 1650. He lived to be only 54 years old, but then he has left such a tremendous thing for us to learn and know the application of algebra in geometry. That's what he has done. And then he started giving this coordinates, which is also known as Cartesian coordinate, after his name, this one. Of course, in French, it is pronounced as Descartes, but as you read it, it is Cartes. So from Cartes, it becomes a Cartesian coordinate, right? Okay. Now, if you want to find out the area of a circle, area of a triangle, then it will be half times. It will come in determinant form. So 1, 1, 1, x1, x2, x3, and y1, y2, y3. This will give you the what? The area of a triangle, whose coordinates are, the vertices have the coordinates this. But then suppose you try to realize that A is coming down gradually. It is just coming down and down. So finally it comes here. That means when A has dropped down to this line, these 3 points will be in a straight line. And as a consequence, as a result, you know, the area of this circle, area of this triangle reduces to 0. So if, so we come to the conclusion that if say x1, y1, that is, you can note down, then x2, y2, and x3, y3 are the three different points are collinear, that is, they lie in the same straight line, then obviously the area formed by these 3 points as vertices will reduce down to 0. Reduce down to 0. That means the area vanishes. So ultimately, this area, when it becomes 0, obviously, you know, ultimately what happens, 1, 1, 1, x1, x2, x3, and y1, y2, y3, that turns out to be a 0, right? Okay, that half doesn't come because half will go and try to divide 0 and it will boil down to 0. So we just remember that if 3 points are collinear, then this particular determinant turns out to be a 0, right? Okay. So that is about the collinearity, or the property when the 3 points are in a straight line. Okay. Now, you know that the general equation, now I'll jump to circle. General equation of a circle is given by what? X square plus y square plus twice gx, try to recall, twice fy plus c is equal to 0. Is that right? Now this is called the general equation, and whose center is given by what? Try to recall. Center is minus z minus f. So where are g and f? G and f are appearing there as a constant. You try to pick up the value of g and f and put it out there. That will give you the coordinates of the center. And whenever we try to know something about a circle, then we must know the center and also the radius. So what is the radius? Radius is given by square root of g square plus f square minus c. Is that right? Right. Okay. Now this becomes a circle, and center is this and the radius is that one. Suppose what happens? The center is the origin. Center is the origin. Okay? Origin we denote by this one, this coordinate 0, 0. So in place of g also it turns out to be 0, f also turns out to be 0, right? So we will get something like what? Something like x square plus y square is equal to some constant k, right? So constant k will be the radius square, which is equal to the radius square. Suppose I write x square plus y square is equal to 2. I write it like that. So you want me to know what is the center and what is the radius. Center obviously will be what? Center will be 0, 0. What about the radius? Radius on the right hand side, which is the radius square. So 2 can be written as root 2 square. So the radius turns out to be what? It turns out to be root 2 units, right? Root 2, that is the unit of length. Now on the other hand, we are just trying to recapitulate. Suppose the equation of a circle is given by this one. Suppose, right? X square plus y square minus 4x plus say 8y minus 1 equal to 0. That becomes the equation of a circle. Now I ask you to find out the center and the radius of this circle. How are you going to find out? We are going to find out the value of the coordinates of the center as well as the length of the radius. Then we must identify what is G and F all about. So try to identify your G and F. And mind you, here all the signs are plus here. So this can be written as what? This can be written as x square plus y square plus 2 times, don't forget 2 is there. In place of G you will write minus 2 x plus 2, that will be 2 times 4y, and plus minus 1 equal to 0. So you can easily identify, by writing this way, you can easily identify the value of G, F and C. What will be G? Tell me. G is minus 2, right? Minus 2. F is 4 and C turns out to be minus 1. So obviously the center is what? Center is minus G minus F. So it will be minus of minus 2 will be 2, minus of plus 4 is minus 4. That's the center, right? And the radius, it will be square root of G square, that is minus 2 square plus F square minus, you got to take care of the sign, of course, properly, right? So you add it up and try to find out. Of course, it may not be a perfect square, you don't care about it. So this is plus 1, the 16 plus 1 is 17, 17 4 is 21, so that is square root of 21 units will be the magnitude of the radius of the circle, that is the length of the length of the radius of the circle. Is that right? Okay. Now we'll try to take up a certain example and then try to work it out. Okay? Right. Okay, I've just written down a question. Prove that the centers of the circle x square plus y square is equal to 1. Now this, you know, the center of this circle is 0, 0, right? And the radius will be obviously 1, right? And then x square plus y square minus 2x minus 6y minus 6 is equal to 0. That is yet another circle. And the third circle is x square plus y square minus 4x minus 12y minus 9 equal to 0 are collinear. It carries 5 marks, and it was set way back in 2004, 2007, 2011 and 2013. And later on, I don't know, of course, I've just collected this years only. And this is the question. I have just put it in the blog. It was set in 2006. You got to show that the centers of the similar type, x square plus x square is equal to 1. And of course, this is different from that. X square plus y square plus 6x minus 2y plus 1 equal to 0. And the third circle is x square plus y square minus 12x plus 4y is equal to 1 are collinear. Well, I have written this hoping that you would be able to do. You please see first how well will I tackle the first problem. All right? Okay, the given circles are x square plus y square plus 1. So clearly the centers of the given circles are okay. You tell me what to do. What are the centers? The first one is 0, 0. What about the second? You can write it as plus 2 into minus 1 into x, right? So your z turns out to be what? Your z turns out to be minus 1, is it? And your f turns out to be minus 3, because you can write it as plus 2 into minus 3. Okay, c need not be known because of the fact that we need only g and f to identify the coordinates of the center, right? So the centers of the given circles are 0, 0 and minus 1 and minus 3. Okay, is that the center? Yeah, g is minus 1, so it will be plus 1, is that right? Plus 1 and 3, because minus z minus f turns out to be 1 and 3. Okay, and what about the third one? This you can write as 2 into minus 2, and this you can write as 2 into minus 6. So your z, first of all, turns out to be minus 2, and f turns out to be minus 6. In that case, minus z and minus f turns out to be 2 and 6. Is that right? And 2 and 6. No confusion? So you have to do the things in a shortcut way, but in the exam, if you've got lots of time, you can write down the given circles are, the first one is that, second one is that, and the third one is that, and accordingly the centers are this, this, this respectively, right? So in the beginning of this class, we have discussed if 3 points are collinear, what do? We can write in determinant form, the area of the triangle formed by those 3 points must be equal to 0, right? So if that turns out to be a 0, then if these points are collinear, that is lying in the same line or same straight line, then the area formed by these points as vertices of a triangle must be 0, right? So that must be 0. So therefore, what happens? Let's try to find out the area is given by half of, what is it? 1, 1, 1 occupies the first row. The second row will be the x coordinate 0, 1, 2, 0, 1, 2, and then the third row will be occupied by the y coordinates 0, 3, 6, 0, 3, 6. Okay, let's see, that is half. Can you do something about this? In a determinant, you remember the property of the determinant. If any element is common either in the column or in the row, we can take it out as a, common. Well, you can see that 1, 1, 1, these are common things, but this is immaterial that you take 1 as common. Here nothing is common, But if you look into this, can you take 3 as common? Answer is yes. Because from 0, anything can be taken common, because 0 can be viewed upon as 0 multiplied to 3. So if you take 3 common, right? If you take 3 common from the third row, mind you, because in a determinant, either in the column or from the rows, we can take common if there are the multiple of the same element. So this is the, what is that? Multiple of 3. So we have taken out 3. So accordingly, we can write what? 0, 1, 2. So after 3 has been taken out, 3 1s are 3, 3 2s are 6. Now what is your idea about this determinant? This determinant has got 2 rows identical. So in a determinant, if 2 rows or 2 columns are identical, then the determinant vanishes. So this will be equal to half into 3 into 0, since R2 is equal to R3. So this turns out to be 0, hence the centers of the given circles, right? Given circle, sorry, let's write in words. Circles are collinear, right? So that's the way you tackle it. And if in the determinant, if you've got nothing common, you can just expand the determinant, try to see whether it will reduce down to 0 or not. That's what you are going to do for this one. Okay? Right. So what is the question here? Show that the centers of x square plus y square is equal to 1. That is the first circle. X square plus y square plus 6x minus 2y plus 1 equal to 0. That is the second circle. And x square plus y square minus 12x plus 4y is equal to 1 are collinear. So I think you have taken down the question. So please solve the question. And if there is any difficulty, you can just, you are always welcome to consult. All right? So that is all. And we'll be doing one more problem, right? And then call it a day. Okay? Right. Once again, we have a problem here which is different from the problem that we have done already, right? Okay, the problem is what? Show that y equal to mx is a tangent, you know about tangent, to the circle. The equation of the circle is given in the general form, that is x square plus y square plus twice gx plus twice fy plus c equal to 0. If this thing happens, that is g plus mf square minus c times 1 plus m square. Well, where do you get this g, m, f, and c, and etc.? That is all here. Y is equal to mx, m is here, g is there, f is there, and c is there. Now you go to attack the problem, but before we go for the problem, let's try to recall some of your algebra that you've already done in the school. Algebra in the sense that the idea of the theory of quadratic equation. Now what did you learn? If the quadratic equation is given like this, ax square plus bx plus c is equal to 0, right? If, of course, here one condition must be mentioned, that is a is never equal to 0. Then this becomes a quadratic equation, because if a is a 0, then it becomes a linear equation. That's the reason that condition is put there, that a is never equal to 0. Of course, b can be 0, c can be 0, right? Okay. Now you also know that to find out, of course, you should be grateful to René Descartes that he has applied algebra into geometry. So how do you get the value of x? X is given to be minus b plus minus square root of b square minus 4ac, is that right? Upon twice a, right? Now here, this b square minus 4ac is known as a discriminant, is that right? It will decide the fate of the roots. Now since plus and minus is there, this quadratic equation has two roots, one with a plus, another with a minus. So this particular quantity, I say quantity or expression b square minus 4ac, if it is greater than 0, then of course it will have positive and different roots, right? So b square minus 4ac, if it is greater than 0, it will indicate what? It will indicate that the roots will be real and different. The roots are real, no? Real and unequal. Let's write it that way, unequal, right? And then if b square minus 4ac is less than 0, that means it turns out to be negative. Less than 0 is negative. You know that the negative, square root of a negative quantity is imaginary. So in that case, the roots will be what? Roots will be non-real. Non-real, that means not real, means imaginary, and unequal. Unequal, owing to the fact that there is plus and minus sign. But if this discriminant b square minus 4ac is equal to 0, then what does it indicate? It will indicate that if it is equal to 0, this underneath the radical sign, everything will be vanishing. So it will be simply minus b upon twice a. That means roots are real. Roots are what? Real. Real and equal. Equal. Right? Now, you must be wondering, why did I spell out all these things? Because of the fact that here, if I draw a circle, right? If I draw a circle and draw a straight line, this straight line will meet the circle in 2 points. That will indicate the 2 roots. But you know that if this straight line comes towards the periphery of the circle, that means towards the circumference of the circle gradually, then ultimately when it just grazes through the circle, then it becomes a tangent. So this particular line turns out to be a tangent. And you know that tangent meets a circle in just a single point, right? And if you come across the algebraic situation where the roots are, roots are 2 in number, then here the roots will be just 1 and they will be equal because they will be coinciding. This point will go here, this point will go here, and they will coincide each other, and when it coincides, this particular line, which is known as a secant, turns out to be a tangent there, right? Tangent. Okay. Now, with this particular knowledge within us, let's try to attack this problem. Okay. Since by question, since y is equal to mx is a tangent to the circle. What is the equation of circle? X square plus y square plus twice gx plus twice fy plus c is equal to 0. Then what do I have? This is a tangent. That means that tangent becomes a part of the circle. The tangent becomes a part of the circle because it lies in one of the points of the circle. So what happens? Y is equal to mx. You can put. So therefore, substituting mx, let's call it 1, in 1, we obtain, what do we obtain? Let's say x square will remain x square, all the x's will remain. Only thing is that in place of y, you will have to substitute it by mx. So we obtain x square plus mx whole square, right? Plus twice gx plus twice fmx, because y has been replaced by mx, plus c is equal to 0. That, of course, we have written it within brackets, so we can write it like this: square twice gx plus twice fmx plus c is equal to 0. Now you can obviously see that the x square is common, so we can take it out. And in these two terms, what is common? X is common and 2 is also common, right? Okay, that can be fished out. So we can write this one as what? 1 plus m square times x square. Is that okay? X square has been taken as common, and there we shall take 2 as well as x common. So let's write it this way: 2g plus fm, right? And then x. Check whether we have done it or not. Twice g into x gives you this term. Twice f into mx will give you twice fmx. Plus c is equal to 0. Now what is this? This is nothing but a quadratic equation of that form. That is, in place of a, we have got 1 plus m square, and in place of b, we have got twice g plus fm, right? This plays the part of b, and this plays the part of a, and c remains as c only. Okay. Now, you know that a quadratic equation will have 2 roots. But here, since the line, this particular line becomes a tangent, so it will have only 1 root, and the roots are equal. So we will have to take into consideration this particular property of the discriminant, right? That particular algebraic property, let's call it. So since the given line is a tangent, it will imply that the, let's call it the equation 2 will have, will have equal roots. I hope it is clear, right? Equal roots. Therefore, Therefore, what happens? B square is twice G plus Fm within the bracket whole thing square. B square minus 4 times AC. 4 times A is 1 plus M square, 1 plus M square. C, of course, in place of CC, that must be equal to 0, right? So what does it give you? That is, this will be 4 G plus Fm whole square. Squaring 2, we get 4, and squaring that one, and that will be equal to, just push it to the other side of sign of equality, 4 times 1 plus M square times C. So this 4's can be cancelled, right? So do we get that? Therefore, G plus MF or FM, what do they want? MF, okay. These are commutative, so you can write square is equal to 1 plus M square C. So shown. So we have used the algebraic properties there in order to solve this geometric problem. Okay. I think that is sufficient for today. We'll be meeting in the next, right? And then try to keep yourself up to date with the knowledge. And if you have any problem with the straight lines, of course, from the straight line also there will be question. And invariably, the circle will have problems. And we got to do a little bit of more problems in circles. And then we'll call it, we'll just try to skip it. And then start the conic sections, okay? That's all for today. Take care. Thank you for listening, right?